Welcome to The Explainer. I am so thrilled you're joining me today because honestly, we are about to deconstruct a masterpiece. You know, when you pour a glass of wine, you're not just pouring a beverage, you're pouring a complex, incredibly dynamic chemical symphony. Today, we're going to break down exactly what is happening inside that glass, transforming abstract chemistry into the very real things you taste, see, and smell.
Sure. There's absolutely a romantic vibe surrounding wine pouring, right? The deep colors, the anticipation, the whole ambiance. But behind all that magic, it is literally hard science. Everything that makes this drink so special comes down to precise chemical reaction.
Okay, to really get this, we've got to talk about one key term, organoleptic. Sounds a bit academic, but it simply means the sensory qualities of a substance. Throughout this explainer, we're going to connect the raw chemical data directly to how a wine actually affects your senses, your taste, sight, smell, and even touch. So to do this, we're going to build a virtual glass of wine from the ground up. Here's our roadmap. First, the bones, which are acids and sugars. Then the body, alcohols, followed by the color, polyphenols. Then the personality, volatiles. And finally, preserving the magic.
All right, let's dive into this. Part 1, the bones, acids and sugars. We are starting right at the foundation with the must, which is just the freshly crushed, completely unfermented grape juice.
Right off the bat, we've got the heavyweight, tartaric acid. This is the main driver of acidity, generated way back in the young leaves and green grains of the vine, and it strongly influences both color extraction and taste. But what's really fascinating here is its partner, citric acid. While it doesn't impact total acidity as much, it acts kind of like a bodyguard. It binds with iron and copper to free the wine from ferric clouding. Basically, it stops the wine from breaking and getting all murky.
Now, check out this transformation. It's the literal magic of fermentation. You start with malic acid, which comes from plant photosynthesis, and it gives that unfermented must a really harsh, aggressive taste. But during winemaking, it transforms into lactic acid. Boom! Suddenly you have softness, delicacy, and friendly harmony. It is a complete sensory turnaround.
Of course, the bones of a wine also completely rely on sugars. Glucose and fructose are the big players, but arabinose, which is a pentose sugar, actually has the greatest impact on that sweet, residual taste. But sugars do way more than just make wine sweet. Get this. When pentose sugars sit in an acidic medium, they can actually form compounds like furfuryl. And believe it or not, those compounds are responsible for a distinct smell that mimics almonds. No way, right?
Moving right along to part 2, the body, alcohols. Now that our bones are set, we're building the actual, literal structure and physical weight of the wine right on your palate.
You know when you swirl a glass and notice that thick, clinging liquid coating the sides? Well, that is largely ethanol acting as the crucial support system for all the other components we're talking about. Ethanol gives the wine its intoxicating strength, its characteristic burning taste, and it even helps dissolve the coloring matter in red wines. But ethanol definitely isn't flying solo here. Enter glycerin, or glycerol. It is a completely colorless, totally odorless, thick liquid. And while it doesn't have a smell of its own, it's the secret ingredient that makes all the other flavor sensations stick around longer. It is the main compound responsible for that tactile sensation of softness. So when a wine feels luxurious, smooth, and velvety in your mouth, you're feeling the glycerin. Okay, part 3, the color, driven by polyphenols. The entire visual spectrum of your wine is dictated by these compounds, deciding whether we are looking at a bright golden white or a really deep bluish red. We can basically split these polyphenols into 2 main camps. First up, the non-flavonoids. Initially, they're colorless, but they can oxidize and cause this really undesirable browning in white wines, or even contribute bizarre odors, like carnations or, strangely enough, pharmacy smells. Then we have the flavonoids. This is where the magic of color truly shines. Specifically, compounds called anthocyanins are directly responsible for giving classic red wines that gorgeous bluish red hue. Now, what's really fascinating here is the physical reaction triggered by flavonols, which include condensed tannins. When you take a sip of a tannic red wine and your mouth instantly feels dry and puckered, that is not your imagination. The condensed tannins are actively combining with the proteins in your saliva in real time, instantly creating that bitter, astringent, dry mouthfeel. All right, part 4, the personality.
volatiles. With the bones, body, and color perfectly in place, it's time for the most complex part of the whole symphony, the volatile compounds that give each wine its totally unique scent profile.
You see, the scent of a wine isn't just static. It actually evolves along a chronological aroma timeline. First, we have primary aromas originating straight from the grape, things like highly fragrant terpenes providing floral notes like rose or pyrazines giving us green bell pepper. Next up are the secondary aromas, which develop during alcoholic fermentation. This is when yeast step in and create esters that contribute deep, fruity aromas. Finally, tertiary aromas bloom during aging. That's where you find those rich notes of toasted almonds, vanilla, caramel, or even leather. But let's be real, sometimes things get a little strange. Have you ever swirled a glass, taken a deep breath, and thought, wait, why does this wine smell exactly like movie theater butter? Or even worse, why does it smell like elementary school glue? Well, the answer all comes down to specific chemical concentrations. For example, a ketone compound called diacetyl is responsible for heavy, rancid butter notes. An ester called ethyl acetate can smell pleasantly like bananas, or actually, scratch that, it can intensely smell like glue, which is a big red flag that acetic acid is forming. If a wine smells wildly animalistic, almost like a horse stable, that's a volatile phenol called 4-ethylphenol, and an aromatic compound known as TDN that literally smells like petroleum. It is an incredibly delicate balancing act for the winemaker. Just look at acetaldehyde. It makes up a whopping 90% of the aldehydes present and is absolutely crucial for defining a wine's aromas. It even combines with coloring matters during aging. Yet, from a physiological standpoint, if you were to isolate it to high purity, acetaldehyde is incredibly toxic. It causes intense nausea, vomiting, and headaches. It's all about precisely managed concentrations. Finally, part 5, preserving the magic, sulfur, and additions. So how on earth do winemakers actually lock in this delicate, volatile chemical symphony without completely ruining the masterpiece? Well, one of the most effective tools is probably sitting right in your medicine cabinet, ascorbic acid. Yep, good old vitamin C. When winemakers need to preserve sensory characteristics in the absence of air, especially those really delicate primary aromas in white, rosé, and sparkling wines, adding ascorbic acid brilliantly maintains those bright, fresh, fruity notes. But, there's definitely a dark side if these additions are mismanaged. Sulfur is a classic preservative for sure, but if free sulfur dioxide levels get too high, it creates a pungent, burnt sulfur odor that just masks all the good aromas. Even worse, during fermentation in poor conditions, the added sulfur can reduce and form hydrogen sulfide, giving you a shocking smell of rotten eggs. Or it can form mercaptans, leaving your supposedly elegant wine smelling like cooked cauliflower, asparagus, or mushrooms. Yikes. And there's this one incredibly specific flaw that judges and sommeliers are always hunting for. When sulfur dioxide levels drop way too low, an additive called sorbic acid can actually be attacked and degraded by lactic bacteria. The resulting chemical compound produces an overwhelmingly strong and distinct odor of geranium stems or leaves. So if your wine smells exactly like a crushed houseplant, the chemistry got wildly out of balance. So what is the big takeaway here? Wine isn't just magic, it is absolutely masterful chemistry. From the aggressive malic acid of the unfermented grape, to that velvety tactile cushion of glycerin, to the surprising buttery aroma of diacetyl, every single sip is a complex, organoleptic equation. The next time you pour a glass, I want you to take a moment to really look, to smell, and to taste. Which part of the chemical symphony will you recognize first? Thanks so much for exploring with me today, and keep asking those fascinating questions.